Hello everyone, my name is Zhang Xiaoyi and I come from University of ISIS. The research title is Optimization Performances Analysis by Different Initialization Methods in Single and Multi-Objective Chaotic Evolution. This is today's outline. I will introduction my research by this 5 part: study motivation, chaotic evolution, and initialization methods, experimental evaluation, conclusion, and future work. First is study motivation. As everyone knows, single and multi-objective optimization problems are classical problems that aim to optimize one or more objective problems and find the most suitable solution. Evolutionary algorithm, as commonly used in solve these problems, has a good robustness and feasibility, but it also faces some problems such as solving convergence speed. So, how to improve the performances of evolutionary algorithm has become an important research topic. Evolutionary algorithm consists of these 4 parts. In early years, researchers didn't pay too much attention to the study on population initialization. They always improve the optimization performances by changing method and crossover. In recent years, with the study of evolutionary algorithm, researchers found that using different initialization methods can effectively improve the optimization performances of evolutionary algorithm. Second part is chaotic evolution and initialization methods. In our research, we use the chaotic evolution as an evolutionary algorithm framework. The biggest difference between CE algorithm and other evolutionary algorithm is the third step. CE introduction chaotic system to generate new individuals and increases search steps through a garden of chaos. As this pseudocode shows, CE generated moted victory through a direction victory D and a chaotic parameter CP, and generated new chaotic victory from moted victory and target victory. Chaotic victory and target victory generated a new population through the selection step. And in this step, direction factor is 1 or minus 1, and the chaotic parameter belong to 0 to 1. Then is the initialization methods. First is the pseudo-random number generator. It is the most commonly used initialization methods, which can generate a random sequence belong to a uniform distribution through Mason twist, like this figure shows. When the dimension of the problem is not very high and the population size is large enough, pseudo-random number generator can provide a uniform distribution initial population for the algorithm, like the right figure shows. Second is the chaotic number generator. It is using a one-dimensional chaotic model, logistic mapping. This is the equation for the logistic mapping. When the nu is 4, the logistic mapping is in a chaotic, and the sequence generated by this model is ergodic and randomness. We can easily obtain a larger number of no-repeat sequence by changing this initial seed, and we can see the distribution of chaotic number generator is like this figure. Third is a quasi-random sequence. It is a low difference sequence technique. There are many methods for the quasi-random sequence, and in our research, we use Sobor sequence as the quasi-random sequence methods. Sobor sequence obtain the uniform distribution sequence by converting the natural number into the binary and mirroring them to the right of the decrement point and multiply them with a special mixture like this table. And we can see that the population generated by the Sobor sequence is a deterministic population. And then is a uniform experimental design. It is a kind of a space filling algorithm. The main object of this algorithm is to obtain the point that can be uniform distribution in the search space through the uniform design methods. And this is the distribution of uniform design methods. And this is the population distribution. And on this basis, we try to use the sequence generated by quasi-random sequence and the pseudo-random number generated as the seed to obtain a new population through the logistic mapping. Then is experimental evaluation. First is initial populator. In our research, we set the initial population is 100 and generation is 500. Cost override and the direction factor rate is 0.7. To evaluation our algorithm performances, we use 3 steps to test our algorithm. For single objective problem, we compare the average convergence speed, and for multi-objective problem, we use inventor degeneration distance and happy volume as the evaluation indices. The equation of inventor generational distance and happy volume is shown in the left. The inventor generational distance means the minimum distance sum between each individual on the real Pareto frontier and the individual set obtained by the algorithm. And the happy volume means the volume of the happy cube enclosed by individuals and the reference point in the target space in the solution set. And in the right is the test function. The test function f1 to f8 is to test single objective problems, and f9 to f13 is to test multi-objective problems. And this is the evaluation result for the single objective chaotic evolution. We can see this table. This is average conversion speed of 13 times for text function f1 to f8. We can see for text function f2 and f4, the pseudo-random number generated with chaotic and quasi-random sequence with chaotic is smaller than other methods. So we apply the fair domain test to obtain average rank for the average convergence speed, and then we apply Bofania test compare the average rank of the fair domain test. We can see this table. The pseudo-random number generator with chaotic and quasi-random sequence with chaotic is smaller than other methods. It means these two composition methods is better than other 4 methods. And then is a multi-objective chaotic evolution. This is the mean happy volume of test function used in experimental evaluation, and this is the inventor generational distance for the test function, we can see it is no significant difference in this. And this is conclusion. We compare single and multi-objective chaotic evolution use 6 initialization methods. For single objective chaotic evolution, the two compared methods showed better performances compared to the 4 basic methods, while there was no significant difference for the multi-objective chaotic evolution. And finally is the future work. For the future work, we will extension more initialization methods, and then we will intention different computation methods. Thank you for your listen.